Hello students, welcome to my YouTube channel. Today we are going to continue with a series of lectures in which we are solving each and every sum from VOR, ADF, RMI chapter in RK Bali. So let's start with today's question 1, which will be question number 14 from this chapter. The question 14 states that the heading read on RMI is what? Is it true heading, a magnetic heading, or a compass heading? So very important point is that an RMI is a combination of magnetic compass, a VOR, and NDB ADF system. NDB is a ground equipment, ADF is your airborne equipment. So it's a combination of this. Next, the instruments look something like this. Okay. So on the top of the instrument will be represented your aircraft heading, which will be your aircraft magnetic heading. Correct answer will be option Bravo. After that, there are two important needles. One needle for VOR, another needle for ADF. So the VOR needle is colored, okay, whereas the ADF needle is not colored, it's hollow. So that is how you differentiate between these two needles. Let's name or let's label it. So over here you will be shown the magnetic heading. Over here this is the head of your VOR needle. It represents QDM, or it gives the information of QDM or magnetic track to the station. The tail of the VOR needle will give you the information of QDR, track away from the station. This needle, the head of this ADF needle, will tell you QDM information, that is magnetic bearing to the station, and the tail of the ADF needle will show you the QDR, that is track away from the NDB station. So this is the entire information about your RMI. The question the heading read is magnetic heading. Next question. An RMI indicates aircraft heading. To convert RMI bearings, okay, that is track of NDB and VOR, to corresponding true. Now RMI indications are all magnetic in direction. Now to convert this magnetic direction into corresponding true directions, what will be the correct combination? So there will be four options or three options given to you. So always remember, when dealing with VORs, the is always magnetic variation is always applied at the VOR station. It's always applied at the VOR station. Whatever the variation where the VOR is located, you will use that variation to calculate the sum. To solve NDB ADF sum, you will use the magnetic variation. You will use the magnetic variation existing at aircraft location. Existing at aircraft location. Remember this. For VOR, the magnetic variation is to be applied at VOR station, the ground equipment. So your VOR, for example, your VOR may be at north 50 degree, 100 degree east. Your aircraft may be somewhere here on 270 radial of this particular VOR. So north 50 degree, same latitude, but longitude may be 020 east. Okay. So next information I am telling you, variation at aircraft is 10 degree west. Variation at VOR is 20 degree west. Fine. Now all radials of VOR are magnetic in direction. So now, as of now, step 1, currently we have the information that aircraft is on 270 radial from VOR. This 270 is true direction. Step 2, apply variation. Now in case of VORs, you apply variation happening at or existing at the VOR station. So ignore this variation, use this variation which is 20 degree west. So variation west, magnetic direction will be best, meaning magnetic will be more than true. So if true is 270, magnetic will be 270 plus 20, which is 290 degree. So final answer will be aircraft is situated on 290 radial. Aircraft is situated on 290 radial after applying magnetic variation. So your answer should be the magnetic radial, not the true radial. So for VOR, always apply variation at the VOR station. For ADF NDB sums, apply variation existing at aircraft. So NDB is the ground equipment, but ADF is airborne equipment. So whatever variation at your aircraft, now aircraft is continuously flying, okay, it's moving from one point to another point. So this variation will keep changing from place to place. So remember that. Question 16. If you correctly tune in a VOT station, now VOT station is a VOR test. T stands for test, a VOR testing facility existing at every airport. So the question states that there is a VOR station to your eastern side. So if this is your northern datum, that means your location is somewhere here. Aircraft location is somewhere here. That means with respect to aircraft, VOR is to its east. Your RMI should show what? RMI means QDM. Should show what? And your OBS should read what? Now you have to remember this point with respect to VOT stations. Okay, irrespective of aircraft position. So irrespective of aircraft position means aircraft may be to the west of VOR, to the north of VOR, east of VOR, southeast of VOR. That doesn't matter. Irrespective of aircraft position, the VOT facility will always show, or it will give the information, will always show 360 from indication or 180 to indication. It will give 360 from indication, that means aircraft, such that aircraft is situated on 360 radial, 360 radial from the VOR. Aircraft is situated on 360 radial from the VOR. So if it's 360 with 360 from, if it shows 180, it should be accompanied by two indication. Okay, so aircraft may not be on 360 radial in reality. It may be in this case, like in case 270 radial, but the VOT facility, the testing facility, won't show 270 radial and from indication. It will still show 360 from indication or 180 to indication. So the OBS reads 360 from or 180 to indication. Remember this. And RMI will read what? So currently, so with respect to RMI, you will get the correct indication, that is VOR is to the east of aircraft as given in the question. VOT station is to the east of aircraft. So aircraft is on what radial? 270. So QDR is 270. QDM, meaning your RMI indication will be 090. Your RMI indication will be 090 indication. Okay, RMI will be 090 indication. OBS will be 360 from or 000 from 1802. Remember this fact for your Viva exams, interviews, and written exams. An RMI, next question, is slaved to a remote indicating compass is unserviceable. So this RMI, which is slaved to a compass, magnetic compass, is unserviceable. Is locked on a heading of 090. So this magnetic compass to which RMI is connected has become unserviceable, and therefore the RMI, which is your instrument, indicates magnetic heading. So that has become locked. 090 is what is showing fixed. Aircraft heading is something else, but 090 is what it is locked at. The tail of the VOR pointer shows 135. The available information from the VOR is what? So like I told you, if this is your RMI and this is your VOR needle, let's say, the head of this VOR needle will always point towards the station, that is QDM. The tail of this VOR needle will always point away from the station, which is QDR. And over here there will be magnetic heading given to you. But in this case, this magnetic heading has become locked. Okay, even if the aircraft is changing its heading, new heading, so that new heading is not getting reflected here. The old heading is locked, which is 090. Next it says the tail of the VOR is showing 135. Now tail is QDR, so QDR according to this example is 135. If QDR is 135, QDM will be the reciprocal of QDR, right? So 135 plus 180, which will be 315. So let's check the options. Option A says radial is unknown and relative bearing is 045. Now see, we know the radial we are situated on, which is QDR. QDR stands for your radial, the radial of VOR on which aircraft is situated. Okay, that is given by the tail of the needle. So we do know the radial we are situated on, which is 135. So option A will be wrong. Also, it states that relative bearing is 045. Now, relative bearing can be obtained from QDM minus magnetic heading. Now, we do know the QDM, which is 315. But what we don't know with certainty is our magnetic heading, which is actually locked because magnetic compass has become unserviceable. So we cannot use this magnetic heading of 090 to calculate a relative bearing, because in actuality the magnetic heading of aircraft may be something else, but we are shown 090 because of unserviceability. So option A eliminated. Option B says we are located on radial 135, which is right, and relative bearing is unknown. Like I said, we cannot find relative bearing because we don't know our heading, correct heading. So this may be true. Option C says radial 135 and relative bearing unknown. So this is correction. This is radial 315. Okay, typing error. So option C was radial 315 and relative bearing unknown. Now radial 315 is wrong because radial 315 is your QDM, which is tracked towards the station. Okay, QDM is not your radial. QDR, which is tracked away from the station, is your radial. What is the job of a radial? The job of a radial is to take you away from the VOR station, is to take you away from the VOR station. That's why another name for radial is QDR, which is nothing but magnetic bearing from the station, away from the station. And all radials are magnetic, so we can either use the word QDR or radial. QDM is not radial. QDM is opposite of QDR. So option C is also wrong because we cannot use the word radial for QDM. Next question, question 18. Simple. Aircraft is tracking towards a VOR station, maintaining 140 radial. So let's draw a VOR station. This is your VOR station, and there is a radial 140. The aircraft is tracking on towards this VOR station with 17-degree port drift. So port drift implies that your heading of aircraft will be more than the track. Okay, track, that is QDM, track to the station. Now in this case, we are tracking towards the station, so it is talking about QDM. Okay, so 17 degrees the value. So QDM, now radial 140 takes you away from the VOR. The reciprocal of 140 is radial 320. Is radial 320. So what will be the heading of aircraft? Heading of aircraft will be more than the track towards the station, which is 320. So it will be more than 320 by 17 degree. That is the drift. So 320 plus 17 is 337 degree. Okay, 337 degree. Next. NDB, so draw a diagram to show the position of aircraft VOR and NDB. VOR A and NDB B are equidistant from aircraft. And NDB, there is another NDB, there is one NDB which is at a relative bearing of 220 relative to aircraft. So let's draw this example. So aircraft is situated on radial 140. So let's draw that aircraft, and the heading of that aircraft is 337. Heading of that aircraft is 337. It is pointing a little bit right hand side of 320. So 337 is your magnetic heading. Okay, 337. Right hand side of 320. Okay, so this will be your VOR. Next is, now we have drawn the position of VOR. We have drawn the position of aircraft on radial 140. We have shown magnetic heading of 337. Now next data says there is an NDB which is at a relative bearing of 220. Now relative bearings are the angle between, relative bearings are the angles between your headings, that is your aircraft heading, and QDM. Aircraft heading and QDM to the station. Okay, so, and it is always measured, it is always measured from heading in clockwise direction. In clockwise direction. Okay, so let's draw this. Now it is 220. Okay, relative bearing of 220, which is more than 180, which is more than 180. So let's start. This entire thing, starting from magnetic heading here, this entire thing will be 180. Okay, this entire thing will be 180. If the question had stated that relative bearing is 180, the NDB would have been directly somewhere here, directly behind this aircraft heading. But we have a relative bearing more than 180, which is 220. So 40 degrees more than 180. So that means we have to extend this arc and go a little bit forward somewhere here. Okay, so NDB is situated approximately somewhere here, and not over here. Okay, so this is entire thing is 180 and plus this extra 40 degree approximate. So NDB is somewhere here. So VOR is directly ahead of aircraft with respect to its position. with respect to its heading, NDB is at 220 relative bearing. Okay, so that is the representation of the question. So they have asked you to draw a diagram to show everything, your aircraft, VOR and NDB. So we have done that. Next they say draw a diagram to show RMI indications. To show RMI indications. So let's draw this RMI. Now RMI is a combination of magnetic heading, and it's a combination another two things, your VOR needle and your NDB ADF needle. Your NDB ADF needle. So VOR and NDB, and this is your magnetic heading. So let's start. Magnetic heading will be how much? It will be 337 because of port drift. Because of port drift, magnetic heading will be 337. Now let's first focus on VOR. Now VOR says we have radial 140 and we are inbound. If you are tracking towards the VOR, the inbound direction will be 320. So in the OBS selector you will put, since you are flying inbound, 320 radial. Okay. So with respect to VOR, QDM is 320. So I will erase this arrow. Okay. And I will draw a new arrow. So 320 radial. 320 will be somewhere here, and 140 will be opposite of that. Let's draw the VOR needle, which will be, I'm using this, so it will be pointing like this. Okay, where the head of this needle is QDM to the station and tail is the radial from the station, QDR. Let's label this. Head is QDM to the VOR, tail is QDR from the station. So blue is for VOR. Okay. Now let's focus on NDB ADF. Now the magnetic bearing to the station will be how much? It will be a relative bearing of, so for NDB, magnetic bearing to the station is magnetic heading plus relative bearing. Magnetic heading is how much? It is 337. Relative bearing was given in the question 220. The addition of that will be more than 360. So when the value is more than 360, you subtract 360 from that. So you get 197. So magnetic bearing to the station or QDM towards the NDB is 1 minus 7. 1 minus 7 will be somewhere here, let's say. And the opposite of 1 minus 7 will be 017. So in case of NDB needle, the head of the needle will point towards 197 and the tail will point towards 017. Okay, so this is for your NDB. So this is the representation of RMI indication. Okay. in case of NDB. So this is how you successfully do this. Very simple. So this sum actually tests your conceptual clarity and understanding. Okay, this question won't be asked in exam, but still it's equally important. Okay, it's at equal footing with all other sums. So this demonstrates your understanding of the chapter, of the theory, and all other facts. With this, we have come to the end of this lecture. So I hope you have understood this lecture very well. Very important MCQ questions for your exam. Keep practicing and keep practicing more and more questions. Also, keep watching the videos I'm going to make. I have already posted. Don't miss them. Very important from all point of view of exam, CPA, ATPA, and airline. And with this, if you have liked this video, hit the like button. Let me know that. Subscribe to this channel if you haven't, and share this video with all your friends. Apart from that, let me know your doubts, questions, feedback in the comment box. So all the best and keep learning. 3 minutes.